So we've come to multiplying and dividing rational expressions, but we're going to compare this to something that we've done in the past since, say, primary school, multiplying and dividing fractions. And as we've seen, that rational functions are actually in a fraction form. And we're going to follow the same simple set of rules that we did for multiplying and dividing fractions for rational functions or rational expressions. So we're going to look at those rules for fractions and try to extend that. So suppose I have 2/3 and I multiply it by 4/5. I will rate this as one big fraction. I'm going to multiply the numerators to each other and multiply the denominators to each other. At this point, I'm going to look to see if I can simplify anything from numerator and the denominator. If I don't have anything to simplify, then I simply go ahead and multiply the numerators. 2 times 4, 8, and multiply the denominators. 3 times 5, 15, and that's how I leave it. To divide two fractions, what I would do, I would rewrite the first fraction. I will make it a multiply, and I reciprocate or flip the second fraction. Then I'm going to follow the same rule for multiplication. I'm going to multiply the numerator, so I'm going to go 2 times 5 in the numerator, and I'm going to multiply the denominator, so 3 times 4. Again, at this point, I'm going to wait and see if I can simplify something before I multiply. So 2 and 4 are both divisible by 2. So I get 1 times 5 in the numerator and 3 times 2 in the denominator, so I get 5/6 in the simplified form. To generalize this idea, you go, okay, if I have product of two fractions, all we need to do is to multiply the two numerators, a times c, and the two denominators, b times d. If I have the quotient of two fractions, I make it into a product by rewriting the first fraction, right? Make it into a product by reciprocating the second fraction, or flipping the second fraction. Once we've done that, we follow the same rule for multiplication, then it becomes a times d over b times c. So simple enough for fractions, should be simple enough for rational expressions. So same set of rules for rational expressions and simplifying and multiplying and dividing rational expressions. So we're going to follow the same thing. We go, okay, I have 2x plus 2 over x minus 3, and I'm multiplying it by 3 over x plus 1. First step, we factor everything. We factor everything. In the first fraction, the numerator 2 can be factored out, so this becomes 2 brackets x plus 1 over x minus 3. Second fraction, I can't really do anything, so it remains 3 over x plus 1. Okay. State the non-permissibles. X minus 3 cannot be equal to 0, so I state that. From that, I deduce that x cannot be equal to 3. X plus 1 cannot be equal to 0, and from that, I deduce that x cannot be equal to negative 1. Step 3, multiply the numerators and multiply the denominators and cancel the common factors of the top and the bottom, just like what we've done with simple numeric fractions. So we've multiplied the numerators and we've multiplied the denominators. The common factor between the top and the bottom is x plus 1. We cancel it out. Then it becomes 2 times 3 over x minus 3, which is equal to 6 over x minus 3. So that's the most simplified form, and the non-permissibles stated. So now we're going to use the same rules for simplifying rational expressions, and we're going to do some examples. If I have this sort of like fraction 4x squared over 3xy, and I multiply it by y squared over 8x. So these are already in factored form. So all I'm going to do, I'm going to write them as one fraction. I'm going to go 4x squared times y squared, and then 3xy times 8x. To make life easier for myself, I'm going to group these things like a little bit easier for myself. So I'm going to go put all the numeric stuff at the beginning. So I have 4 on top. That's the only numeric part of the numerator. In the denominator, I have 3 times 8. Then I'm going to put the x terms next. So I have x squared, and on top I'm going to put it there. At the bottom I have x, and I have another x. In the numerator I have y squared. I have the y terms put next, and I'm going to have y in the denominator. So this way it's grouped properly, and I don't have to sort of look for it, or just in case sort of I misplace it, I don't forget to sort of count it in. You go, okay, now I have 4 divided by 3 times 8. Between 4 and 8, I can cancel 4 on top, and I have 3 times 2 at the bottom. Between x squared and these two x's that are multiplied at the bottom, I can cancel them out. So all the x's disappear. And then I have y squared divided by y. The y at the bottom cancels that square term on top. So I get y over 6 as the simplified form of this. I'm going to assume that all the denominators are non-zero, right? So I don't have to state the non-permissibles. I think we've sort of established that we have to state the non-permissibles. So I'm just going to leave that. I'm going to do the multiplication and simplification with these examples. So you guys just go ahead and do that. So now I have a multiplication of 2 fractions with more than just like factored terms. I have a squared minus a minus 12 divided by a squared minus 9 multiplied by this second fraction, a squared minus 4a plus 3 over a squared minus 4a, and I need to simplify this. So our first step was to factor everything, right? So that's what we're going to do. Factor everything completely. So if you have everything in a factored form, things will look a lot easier. So suppose I have 12 divided by 16. Right away, I may be able to see it, but if they are big numbers, I can't. But if I have it in factored form, 2 times 2 times 3 divided by 2 times 2 times 2 times 2, if I have it this way, I can see that, those small factors can, can quickly simplify and cancel out. So that's what I'm going to do. I'm going to factor the numerator of the first one. It gives me a minus 4a plus 3 over, and the denominator of the first fraction is the difference of squares. I'm going to write it as a minus 3 times a plus 3 multiplied by the numerator of the second fraction. I'm going to write it as a plus what? Or a minus 1 times a minus 3. Yeah? And the denominator, I can take a as a factor. I get a squared, or I get a minus 4. A minus 4. Now I'm multiplying these two fractions to each other, so I have to multiply the numerators, and I have to multiply the denominators right across. So instead of rewriting all of this, I'm going to extend this fraction line and just say, okay, the numerators are multiplying and the denominators are multiplying. Now I'm going to look for common factors in the numerator and the denominator. So look for common factors. So common factors of top and bottom. Right? So if I'm looking for numerators, the factors of numerator and denominator that are the same, the first thing that that sort of comes to our attention is a minus 4 is common between the numerator and the denominator. Then I go, okay, a plus 3 is common. I cancel them out. And a minus 3 is common. And I'm going to cancel them out. So I'm going to rewrite this in the simplified form. What's left over in the numerator is a minus 1. And what's left over in the denominator is a. So this is the most simplified form of this multiplication of this, these two rational expressions. Now we have a you-do. I'd like you guys to give this a shot, and we'll come back in a couple minutes and do this together. Go for it. Okay, so let's do this one quickly together. I'm going to factor everything. I'm going to factor the numerator of the first one. And the numerator of the first one, it'll be x plus 4 and x plus 1. I'm going to factor the denominator. I'm going to take out the GCF first. 2 is the greatest common factor. I'm going to take that out. This becomes x squared minus 4x plus 4. So this is an x minus 2 squared times. I'm going to take out the GCF of the numerator. This is 4 times x minus 2. The denominator of the second one is x minus 1 times x plus 1 in the factored form. Now I'm going to extend this fraction line, and I'm going to make it a multiplication of the numerators and multiplication of the denominators. Now I'm going to look to cancel what's common between the numerator and the denominator. X plus 1 is common between the numerator and the denominator. I cancel them out. X minus 2 is common. I'm going to cancel it out. And I think that's about it. And 4 and a 2, this is 1, and that would be a 2. So this becomes x plus 4, 2 of them, over x minus 2 times x minus 1. And that will be the simplified form of this. If you were to state the non-permissibles, as Joshua was saying, you look at the factored form, the state that it is in the most factored form, and then you look at all the denominators, right? And you look to see what makes the denominator equal to 0, and those would be the non-permissibles. Now, we're going to look at dividing rational expressions, right? So suppose I have the division of x squared minus 4 over x squared minus 4x by x squared plus x minus 6 over x squared plus x minus 20. So I'm going to factor everything first. I'm going to factor everything first. So this would be x minus 2, x plus 2 over, I'm going to take the greatest common factor of the denominator, which is x, out, and I'm left with x minus 4. I'm going to make this a multiply, and I'm going to flip the second fraction. X squared plus x minus 20, just like what we do with fractions. Denominator becomes x squared plus x minus 6. So the first one was x minus 2 times x plus 2 over x times x minus 4. Now the second one becomes x minus 4 times x plus 5 in the factored form over x minus 2 times x plus 3. Now I'm going to look at extending the fraction line, right, and make it multiplication of the numerators over the multiplication of the denominators, and I'm going to look for common factors of the numerator and the denominator. X minus 2 cancels x minus 2. X minus 4 cancels x minus 4. And I don't think I see any other common factor between the numerator and the denominator. So now I'm going to go, this is x plus 2 times x plus 5 over x times x plus 3. And that's the most simplified form. Okay, and we're going to do one more division. I'd like you guys to try it first. Go for it. Okay, so we're going to factor the numerator of this one. A times c is negative 8. I'm looking at factors of negative 8 that add up to negative 7. So I'm looking at 2n squared. Factors of negative 8 that add up to negative 7 are minus 8 and plus 1. I'm going to do the same thing for the bottom. Factors of negative 36 that add up to negative 5 are negative 9 and positive 4. So 6n squared minus 9n plus 4n minus 6. I'm going to make this a multiply. I'm going to flip the second fraction. 12n plus 8. Do the same thing. Factors of 4 that add up to 4 becomes a 4n squared plus 2n plus 2n plus 1, right? Now I'm going to group them together. So the first group gives me a common, I take the GCF of the first group, 2n squared. So grouping the first two, I take out the GCF, 2n, it'd be n minus 4 plus n minus 4 over, I do the same thing for the denominator. I have 3n as the GCF. I get 2n minus 3 plus, I take 2 as a common factor of the last 2 in the denominator. I get 2 as the common factor. I get 3n minus, or 2n minus 3 multiplied by, I'm going to take 4 as a common factor in the numerator. Here I get 3n plus 2. First two terms, I'm going to take out the GCF, which is 2n, and I get 2n plus 1 plus 2n plus 1 grouped at the end of that. Now I'm going to write them in as product of factors. So I'll get n minus 4 as the common factor taken out. 2n plus 1 is the other factor. The denominator is going to be 2n minus 3 times 3n plus 2 multiplied by 4 times 3n plus 2 is in the numerator, 2n plus 1 is the common factor, and 2n plus 1 is the other factor. Now I'm going to look for common factors of the numerator and the denominator to cancel out. Okay, I have 2n plus 1 occurring both in the numerator and the denominator. I can cancel them out. 3n plus 2 can be canceled from the top and the bottom. Is there anything else? I think I'm done. And you go, okay, 4 times n minus 4 over 2n minus 3 times 2n plus 1 would be the most simplified form of this. So you guys have some homework to do for this section, which is the 2.2. Make sure that you do some of the high-level questions, the ones at the end. If you start at E and you think it's a little bit too much, go back and start doing start by doing some of the easier ones, which are A, B, C, D, some of those. So once you warmed up, then you can do you can do more of the high-level ones. Alrighty. So that's for today's lesson.